In this video, I'm going to walk through how I configured an AWS Site-to-Site VPN connection between my home network and AWS. And more importantly, I'll show you a gotcha that caught me out at the end, where IPSec and BGP were both up, but traffic still wasn't flowing. Here's the network topology for the environment. On the AWS side, I have a VPC with public and private subnets and Linux instances running in both subnets for connectivity testing. We built this in the previous video. You can check it out if you are interested. On the home network side, the Cisco IOS router acts as a customer gateway. The Linux machine represents a local host on the home network, and both devices are on the same LAN as the internal interface of the home router performing sourcenet. The red dashed line between the Cisco VPN router and the AWS Virtual Private Gateway represents the two IPSec VPN tunnels carrying BGP routed traffic, simulating a classic corporate branch office connection. That's what we are building in this video. The setup starts in the AWS console, and I first navigate to the Customer Gateway section. The Customer Gateway represents a Cisco IOS router on my home network. Here we set the name for the Customer Gateway. We set it as up247 CGW. We leave the BGP ASN as default. And then we set the public IP of my home internet connection. For the rest, we leave as default. Next, I create the virtual private gateway. This gateway terminates the VPN tunnels on the AWS side and participates in BGP route exchange with the Cisco router. The virtual private gateway acts as a responder. It waits for my Cisco router to initiate the tunnels. Now I create the site-to-site VPN connection. I associate the customer gateway with the virtual private gateway and enable dynamic routing using BGP. Here I select the virtual private gateway and the customer gateway I created earlier. For everything else, I leave it as is because they are exactly what I want. Once AWS provisions a VPN connection, two redundant IPsec tunnels are automatically created for higher availability. At this point, AWS allows me to download a vendor-specific configuration template. I select Cisco IOS and download the generated configuration file. This generated configuration contains IKE Phase 1 settings, IPsec Phase 2 settings, tunnel interface definitions, pre-shared keys, and the BGP neighbor information. This makes the Cisco site setup significantly easier because AWS already provides the required tunnel parameters. With the downloaded file, I can start configuring the Cisco IOS router on my home network. The file contains two tunnel configurations that include IKE and IPsec settings, the tunnel interface, and the BGP neighbor configuration associated with each tunnel. Before applying the configurations to the router, I had to make a few adjustments to this AWS generated template. Since the Cisco router is connected on the LAN side of the internet router, I need to specify the private IP address of the Cisco router. So I switch to the console of the Cisco router and get the IP from the interface output. Here I just paste the IP address in place. This one is for the IKE policy, but there are multiple spots where I need to do the same thing. The next one is for the IKEv2 profile. We just paste in the same IP. The next spot to do that is in the configurations of the tunnel interface. In this configuration template, BGP is the last component for a tunnel interface. Here I need to specify the home subnet to be advertised through BGP. Once I do that, tunnel 1 configuration is completed. I will need to do the same thing for tunnel 2 configuration. So here again in tunnel 2 configuration, we set the same IP for IKE policy and the IKE profile. Next, we set it in tunnel 2 interface configuration. The last piece I need to adjust is the home subnet for BGP advertisement. After making these changes, I began applying the configuration to the Cisco router. I start with the tunnel 1 configuration. This includes IKE and IPSec settings, the tunnel interface, and the BGP neighbor configuration associated with the tunnel 1. So I just highlight the whole tunnel 1 configuration, copy it to the Cisco console, just paste it there. As soon as I paste in the tunnel 1 configuration, the tunnel interface comes up almost immediately. Right after that, the BGP neighbor relationship also establishes successfully. The Cisco command show IP BGP summary also confirms the BGP neighborship is up. The command show IP interface brief also confirms the tunnel interfaces is up. Next, I apply the tunnel 2 configuration. AWS automatically creates 2 VPN tunnels for redundancy and failover, so both tunnels are configured independently. Again, as soon as the tunnel 2 configuration is pasted into the Cisco router, the tunnel interface comes up and the BGP session establishes very quickly. One important detail here is that the Cisco router initiates both IPsec tunnels toward AWS. AWS acts as a responder by default. Because my Cisco router sits behind a typical home internet router performing sourcenet, I do not need to configure any port forwarding on the home router. The outbound UDP sessions on ports 500 and 4500 are automatically maintained in the net translation table by the home router. So as long as the Cisco router can initiate outbound connectivity to AWS, the VPN tunnels can establish successfully through NET. I can see that the BGP sessions between the Cisco router and the AWS Virtual Private Gateway are now established successfully on both tunnels. The 2 IPsec tunnel interfaces are also up. Phase 1 IKE status is also showing ready for both tunnels. IPSec Phase 2 is verified by seeing both encrypting and decrypting traffic on both tunnels. At this point, everything seems fine. VPN tunnels are up, BGP is established, but there's one issue you're just about to see next. First, let me get the IP addresses of the EC2 instances. Now I'm in the terminal of the Ubuntu Linux machine on the home network. It's on the same subnet as the Cisco VPN router. As you can see, it still has trouble reaching the EC2 instance in AWS. Back in the console of the Cisco VPN router, I can see there's no routes from AWS than by BGP. The show IPBGP summary command confirms there's 0 prefixes learned from AWS side of the BGP. And I also want to check if the local subnet is being advertised to AWS. The output shows it is. Now I'm checking the same for tunnel 2. So as you can see, the local subnet is being advertised on both tunnels to AWS, but the local BGP is not receiving any routes from AWS. And the inbound route filtering is not configured on the Cisco router for any BGP advertisement from AWS. All these are telling me that something is not right at the AWS side, and that is preventing it from sending the route and possibly accepting the routes advertised by the Cisco router. So I get back into the VPC console. First, I check the VPN connection. Everything looks good in here. But as soon as I click the private virtual gateway, I can see it is still detached from any VPCs. This is an easy mistake to make during AWS VPN configuration. Without attaching the virtual private gateway to a VPC, the VPN tunnels can still establish, BGP can still come up, but the VPC itself is not actually connected to the VPN routing domain. The fix for this is easy. Just get into the drop-down and select the right VPC and attach it. Once that's completed, the AWS side is now properly connected to the VPN infrastructure. Now I'll head back into the Ubuntu Linux and do some testing. As you can see, the traffic is still not flowing. I confirm the gateway IP for the default route is correctly set to the Cisco router. Apparently, there's still a second thing missing, route propagation. Even though BGP is up and the virtual private gateway is now attached to the right VPC, AWS does not automatically inject BGP learned routes into the route table of each subnet. Route propagation needs to be explicitly enabled on each route table for it to send and receive traffic through the VPN. One quirk I run into here in the route propagation tab of the route table is I don't see the virtual private gateway even though I have attached it to the VPC. And this is the case for the route table of both the private subnet and the public subnet. I had to refresh the web page in my browser and click into the route propagation tab again to find the virtual private gateway whose propagation setting is still no. And this is the case for both the private subnet and the public subnet. Now that I find where the issue is, the fix is easy. Just edit the route propagation and turn the setting on. As soon as I do that, the route entry for my home subnet pops up in the routing table. Now I do the same for the public subnet. The route for my home subnet shows up as expected. Now I'll go back into Ubuntu Linux to do some more testing. There it is, beautiful continuous ping replies I have been striving to see. I can test further by SSH into EC2 host in AWS and connect back. The permission issue on screen is because I didn't properly set up key pair for the current user login, but I did properly for root user, so I'm switching to root and trying again. I'm able to SSH into the EC2 host on private subnet in AWS from the Linux host on my home network. And from there, I can reach back to the Linux host on my home network. SSH also works for connection back over the VPN. Now I'm making a test connection to the EC2 host in public subnet of AWS as well. And everything looks good here as well. At this point, the full hybrid connectivity is operational. I can now connect to AWS from the home network and reach the home network from AWS. Two things caught me out in this setup, and both are worth remembering. First, the virtual private gateway must be explicitly attached to a VPC. Creating it is not enough. If it shows as detached, BGP and IPSec can still come up, but no traffic will flow into the VPC. Second, route propagation must be manually enabled on every route table that needs to reach the remote network. BGP being established does not mean your route tables are automatically updated. It is a separate manual setup. This is a great example of real-world hybrid cloud troubleshooting using AWS Site-to-Site VPN and BGP dynamic routing. If you found this useful, subscribe for more cloud networking and infrastructure integration content. Thanks for watching.